Good evening, students. Very good evening. Two papers of our board has been conducted yet. अब तक के लिए 2 पेपर हो चुके हैं, मैथ्स का और साइंस का. थोड़ा मैथ्स का आपका डिफ़िकल्ट रहा था, लेंदी रहा था, डिफ़िकल्ट से ज़्यादा लेंदी रहा था, लेकिन कोई नहीं, अभी भी हमारे पास बहुत टाइम है रिकवर करने के लिए, अपने परसेंटेज को अच्छा बनाने के लिए. तो हम उसी कोशिश में आपके साथ हैं, इसलिए हम आपके लिए लाए हैं फिज़िक्स मैराथन. योर नेक्स्ट एग्ज़ाम इज़ टू बी हेल्ड ऑफ साइंस. साइंस की दूसरी एग्ज़ाम रहेगी आपकी 3 दिन बाद. ओके, तो उसी के लिए हम आपके साथ ये फिज़िक्स मैराथन लेके आए हैं, जिसमें हमने ढूंढ के फिज़िक्स के 60 to 65 क्वेश्चंस निकाले हैं. बेसिक से बेसिक क्वेश्चन से लेके अच्छे कॉन्सेप्चुअल क्वेश्चंस सॉल्व करवाने के लिए. पूरी तरह से आप सॉल्व करेंगे, इसको ध्यान से समझेंगे तो आपके सारे कॉन्सेप्ट रिवाइज हो जाएंगे और आपके लिए एक अच्छा सा बेस क्रिएट हो जाएगा. ओके, चलो, तो विदाउट वेस्टिंग मच अमाउंट ऑफ योर टाइम आई वुड लाइक टू स्टार्ट द क्लास. हाँ, ओके, लेट अस गो विद द फर्स्ट क्वेश्चन. ओके, पहला क्वेश्चन क्या कह रहा है? कैलकुलेट द नंबर ऑफ इलेक्ट्रॉन्स कंस्टिट्यूटिंग 16 कूलम्स ऑफ चार्ज. नंबर ऑफ इलेक्ट्रॉन्स फाइंड करने हैं 16 कूलम ऑफ चार्ज में. सो योर एन इज टू बी फाउंडेड. चार्ज हमें 16 कूलम दिया गया है, बराबर है, और हमें फाइंड करना है नंबर ऑफ इलेक्ट्रॉन्स. नंबर ऑफ इलेक्ट्रॉन्स कितने होते हैं? सो हाउ विल वी फाइंड दैट? हाउ इज इट दैट वी आर गोइंग टू फाइंड दिस थिंग? तो उसके लिए हमें क्या पता होना चाहिए? फॉर्मूला ऑफ चार्ज. वी शुड नो द फॉर्मूला ऑफ चार्ज. 16 कूलम, 1 कूलम में 6 इंटू 10 रेज टू माइनस 90, 16 इंटू 10 रेज टू माइनस 9, सॉरी 6 इंटू 10 रेज टू 18 इलेक्ट्रॉन्स होते हैं. एक कूलम में इतने इलेक्ट्रॉन्स होते हैं, हमें नंबर ऑफ इलेक्ट्रॉन्स फाइंड करने हैं. ओके, सो 16 कूलम वुड बी हाउ मच? ओके, 16 इंटू 10 रेज टू 18. 16 कूलम में कितने होते हैं? 1.6 इंटू 10 रेज टू 18 इलेक्ट्रॉन्स 16 कूलम में कितने होंगे? सो लेट अस से दिस इज x. सो योर x वुड बी इक्वल टू 16 अपॉन 1.6 इंटू 10 रेज टू 18. ओके, ये चले जाएंगे ऊपर. सो x इज इक्वल टू 16 मल्टीप्लाइड बाई 10 रेज टू माइनस 18 अपॉन 16 इंटू 10. okay, which will be equal to 10 raised to minus 17 electrons. Okay, that will be your answer. Now next question. The current of 0.5 ampere is drawn by the filament of an electric bulb for 20 minutes. Find the amount of electric charge that follows through the circuit. Sir, हाँ, current of 0.5 ampere is drawn by the filament of an electric bulb for 20 minutes. Find the amount of electrons charge that flows through the circuit. Is given to us. I is 0.5 ampere drawn by the filament of electric bulb for 20 minutes. Time is given to us as 20 minutes. Find the amount of electric charges that flows through the circuit. Okay, so उसके लिए हम क्या करेंगे? Q is equal to IT. This formula will use, and hence our answer will be equal to 0.5 multiplied by 20. Okay, but time हमेशा सेकेंड के फॉर्म में होता है, इसलिए multiplied by 60 also. Okay, so what will be the answer of it? 5 by 10 into 20 into 60. 10 600. Okay, so again, do not forget to write the charge, so that the unit charge is equal to 600 coulomb. Okay, so next. A 9-volt battery. A 9-volt battery is connected across an unknown resistor that there is a current of 3 milliampere in the circuit. Find the value of the resistance of the resistor. We want to find value of the resistor of the resistance. Okay, so it's directly the Ohm's law. It's directly the Ohm's law. So R is equal to V by I. R is equal to V by I, where your V is 9 and your current is 3 milli, 3 into 10 raised to minus 3, which will be equal to 3 into 10 raised to 3 ohm. This would be your answer. Okay. So next. An electric heater draws a current of 11 ampere. Current is given to us as 11 ampere when connected to 220 volt. Volt is also given to us. Volt is also given to us. Mains supply. Calculate the resistance of the filament. Resistance is to be found of that filament. Okay. So here also same thing, we'll be using the Ohm's law, where R is equal to V by I. V is 220 upon I is 11. So we can say that 20 ohm resistance will be applied over there. Clear? Simple. Next question. How much current will an electric bulb through a 220 volt source if the resistance of the filament of the bulb is 1100 ohm? So over here they have given resistance R and voltage. Again we'll be using Ohm's law. Where R is equal to V by I. So 1100, or V is equal to IR, where I is equal to V by R. V is equal to 220, R is equal to 1100. 11 tens are 11 twos are 2 fives are, or 0.2 ampere. Again I am reminding, do not forget to write the units. Because if you lose the unit, your marks will be deducted, although everything is correct. Next. The potential difference between the terminals of an electric heater is 250 volt. Potential difference is 250 volt. When it draws a current of 10 ohm. Okay, here V is given. Current of 10 ampere. So and I is given. What current will the heater draw if the potential difference is increased to 300 volt? So this is, you can say, this is V1. This is V2, this is I1 given to us, and we are to find I2. Now Ohm's law states that resistance remains constant. So with the help of V1 and I1, we will find R. R is equal to V by I, over here V1 upon I1, which is equal to 250 upon 10, 25 ohm. Now we are to find another current. So V2 by I2, where R is given to us as 25, V2 is 300, and then I2 is to be founded. So I2 is equal to 300 upon 25. 12s are. So I2 is equal to 12 ampere. Your current will be equal to 12 ampere. Okay. Next, what is the shape of the graph obtained by the plotting potential difference across applied across a conductor against the current flowing through it? This is a direct question. What kind of graph it would be, as potential difference and current is directly proportional to one another? So it would be a straight graph. It would be a straight graph. So for this, first answer is straight graph. Straight graph. What does the slope of V versus I graph at any point represents? V versus I graph represents resistance. It represents resistance. It represents resistance. Next, if 6 ohm resistance wire is doubled on itself, your resistance is given to you as 6 ohm, आपको resistance दिया गया है, wire is doubled on itself. Calculate the new resistance of the wire. We have to find new resistance of the wire if it is been doubled. Okay. For this, what will you do? That as the length of the as resistance wire is been doubled, so new resistance would be equal to, or you can say new R is equal to old R, original resistance, divided by 2 square. Using that, 6 upon 2 square, which is 4, 1.5. Resistance would be 1.5 ohm. Okay. So whenever such kind of questions comes, you can use this relation. If it has been thrice, then you will use 3 to the power 2. Okay. So next, the electrical resistivity of a copper and aluminum are this. Resistivity means rho is given to us. Rhos are given to us. This is rho 1 and rho 2. Represent respectively. Which is better conductor? Resistivity shows us that which particular compound is more resistive. कौन सा ज़्यादा resistive है? तो जिसकी वैल्यू ज़्यादा होगी वो ज़्यादा रेजिस्टेंस दिखाएगा. तो एल्यूमिनियम की रेजिस्टिविटी ज़्यादा है तो ज़्यादा रेजिस्टिव दिखाएगा. वो ज़्यादा रेजिस्टिव है तो बेटर नहीं है हमारे लिए. तो कौन सा बेटर रहेगा? कॉपर हमारे लिए बेटर रहेगा. ओके, सो कॉपर इज द आंसर, एज इट इज लेस रेजिस्टिव. The resistance of an electric wire of an alloy is 100 ohm. R is given to you. If the thickness of the wire is 0.001 meter and the length is 1, so thickness, so diameter is given to you and length is given to you. Find its resistivity. We have to find rho. What is rho? So for that, what is the formula? R is equal to rho L by A. Resistance is 100. Rho is to be found. L is 1 meter. Area for here, it is a wire. So it is cylinder. In cylinder, radius is given to you as 0.001 by 2. So what will be the area, cross section area for the cylinder? It would be a circle, so pi r square. Hence 22 by 7 multiplied by 0.001 upon 2 square. So your rho is equal to 100 multiplied by 22 upon 7 multiplied by 0.001 by 2 square. So if you will calculate this, I remember it by 22, or let us write it as 3.14. 22 by 7, instead of 22 by 7, let us write it as 3.14 multiplied by 0.001 and square of it. It will become 1 into it is 10 raised to minus 3 minus 6 whole divided by 4 whole divided by 4. Okay. 7.85 into 10 to the power minus 4. 7.85 into 10 raised to minus 4 rho will be your answer. And what is the unit for rho? It is ohm meter. Rho is ohm meter. Okay. So a piece of wire is redrawn by pulling it until its length is doubled. So your original length, let us say your L1 was L, your L2 become 2 times L, and the area is halved. A1 is A, A2 is A by 2. Compare the new resistance with the original resistance, because rho remains constant. So let us find R1. R1 is equal to rho L1 by A1, which is equal to rho L by A. And R2 is equal to rho L2 by A2. This is equal to rho L2 is 2L and A is A upon 2. So I can write it as 4 rho L by A. So what can I say? That my new resistance or R2 is actually 4 times R1. R2 is 4 times R1. Okay, so you will write a statement over here that as the length will be doubled, length जब double हो जाएगी और आपका area आधा हो जाएगा, तब आपका जो resistance है वो 4 गुना बढ़ जाएगा, पुराने resistance से 4 गुना बढ़ जाएगा. A silver wire of resistivity 1.7 into 10 raised to minus 8 ohm meter, rho is given to us, has a diameter of 0.2 mm. D is given to us. What will be rho is equal to 1.7 into 10 raised to minus 8 ohm meter, and diameter is equal to 0.2 mm, and you can write it as 0.2 into 10 raised to minus 3 meter. What will be the length of its wire to offer a resistance of 2 ohm? R is 2 ohm and length is to be found. Okay. Again, R is equal to rho L by A. L is equal to R into A by rho. R is given to us as 2. Area, for area pi r square, it would be pi r square. So 22 by 7, or just write it as 3.14 multiplied by radius would be 0.1 into 10 raised to minus 3 whole square, divided by rho will be 1.7 into 10 raised to minus 8. Now 7.2, sorry, 1.7, 7 to the upon 4, 203, 3.4 it is. So it is slightly bigger than that, but conventionally you can do some cuttings over here as 2za, and your length would be approximately, write it as approximately 4 times 0.1 square. So it will be 1 into 10 raised to minus 2 into 10 raised to minus 6 divided by 10 raised to minus 8. So this will be cancelled out. So length is approximately 4 meter approximately. Actually it is slightly less than that. It is slightly less than that, but it is tough to calculate such kind of question. So whenever such kind of question is given, जब भी ऐसा कोई question दिया जाए तो हमेशा approximately लिख देना चाहिए, बराबर है. अगर possible है तो पूरा calculate करो exam के time पे, बराबर. But we can understand that in exam we do not have much amount of time. So what will we do? We will just write it approximately. What will be the length of a silver wire of resistance 6 ohm if the length of a similar wire is 80 centimeter and has a resistance of 3 ohm? Okay. Again, same kind of question. It is about R is equal to rho L by A. So you do this by yourself. A conductor of length 65 centimeter has a resistance of 4 ohm. Calculate the resistance of the same conductor of length 260 centimeter. Same length is given to you. Same conductor means rho is the same and area will also be the same. So there is no change in area. Again, same thing you will apply. Rho R is equal to rho L by A, and you will be able to find your answer. An electric lamp of resistance 100 ohm, a toaster of resistance 50 ohm, and a water filter of resistance 500 ohm are connected in parallel. All these three are R1, R2 and R3 are connected in parallel connections to a 220 volt. Voltage is given to you. What is the resistance of electric iron connected to the same source that taken as much current as all the three appliances, and what is the current through it? You have to find current also, individual and total current. Actually total current only. Total current only. You have to find total current. So for that you are required to find total resistance also. So 1 upon resistance in parallel connections is equal to 1 upon R1, 1 upon R2, 1 upon R3, 1 upon 100, 1 upon 500, 1 upon 50. So here if we will take the LCM, so this is 10 and over here 5. 5 plus 1 plus 10 upon 500, 1 upon RP. RP would be equal to 500 divided by 5 plus 1, 6 and 16 over here. This will be your total resistance in parallel connections. Okay, now you know RP. What will you find? R is equal to V by I is equal to V by R. V is 220, R is equal to 500 divided by 16. 220 multiply 16 upon 500. 0 gets cancelled out. Let us multiply 2 in denominator and numerator. 16 2s are 32. 32 times 2, 64, 64 and 64. 704. 704 and in denominator will be 100, so 7.04. Current would be 7.04 ampere. Clear? Very simple. Chalo. Next. What is the highest, the lowest total resistance that can be secured by combinations of 4 coils resistance 4, 8, 12 and 24. So for it is quite clear. For highest, what can we do? We can actually find in series connection. Resistance when appeared in series connection, it would be the highest one, and resistance when it will be in parallel connection, it will be the lowest one. So for that, what will we do? We'll find RS, which is equal to R1 plus R2 plus R3 plus R4, which is equal to 4 plus 8 plus 12 plus 24, and here 24 to the 48 RS. this would be the highest one. Don't forget to write ohm. This would be the highest one. And Rp, 1 upon Rp, 1 upon R1, 1 upon R2, 1 upon R3, 1 upon R4. Always write the formulas first. In each and every question, try to write each and every formula first, so that if by mistake you may have made some calculation error, you will still get some marks for the formulas. है ना? तो फॉर्मूला लिखना बिल्कुल भी नहीं भूलना. अगर आपने आगे जाके कहीं पर गलती करी हुई है कैलकुलेशन में, फिर भी आपको फॉर्मूला की वजह से मार्क्स जरूर मिलेगा. दैट इज मैंडेटरी टू गिव मार्क्स फॉर फॉर्मूलाज इन CBSE बोर्ड. ओके, चलो. So 1 upon Rp would be equal to, now 6 4s are 24, so 6 will be over here, 8 3s are 24, so 3 will be over here, 12 2s are and 1 upon 24. So Rp would be equal to 24 divided by 6 and 6 12. 3 4 so 2s are, so your parallel connection would be 2 ohm. So the lowest one is 2 ohm and the highest one is 48 ohm. Okay. 4 resistors are connected in series such that their total resistance is 50 ohm. If the resistance of 3 resistors is 5, 10, 15 respectively, find the resistance of the 4th resistor. Okay. So they are connected in series connection, and total resistance is 50 ohm. So you can say that Rs is equal to 50 ohm, R1 is equal to 5, R2 is equal to 10, R3 is equal to 15, and we are to find R4. So Rs, R1 plus R2 plus R3 plus R4. Here 50 is equal to 5 plus 10 plus 15 plus R4. So what will you get your R4 as? R4 is equal to 50 minus 10 and 20. 10, 30. R4 would be equal to 20 ohms. And you will be having 20 ohm. Okay. चलो. चलो. Total resistance is equal to, 4 resistance of 3, 5, 7 and 10 are connected in a series connection to a 10 volt battery. You are to calculate the current in 5 ohm resistance, only in 5 ohm resistance. Okay, but here it is in series connection, so current will be equal for all 4 of them. Current would be similar and equal for all of them. So here the simple thing is you have to find actual total resistance, and then with the help of total resistance you will find your current. So your total resistance would be equal to 3 plus 5 plus 7 plus 10, which is equal to 25. Voltage is given to us as 10 volt. So your V is equal to IR. I would be equal to V by R, which is equal to 10 upon 25. 5 5s are 5 2s are 0.4 ampere. What will be the current? 0.4 ampere. है ना? Simple it is. Next, a charge of 90,000 coulombs flows through a conductor. So this is Q given to us at a potential difference of 60 volt. V is given to us for 1 hour. What is the magnitude of heat energy produced? Heat energy. So first of all, we need to remember the formula of heat energy. What is heat energy? H is equal to VIT. Voltage is given to us as 60. Current, actually I don't know. So current, for that we will use the formula for current. Current is equal to charge per unit time. Charge per unit time. So Q by T into T. So what will be happening? T and T gets cancelled out. 60 multiplied by 90,000. Okay. Hence 9 6 are 54. 54 lakh energy. So joule over here. Joule of energy will be released. Okay. Okay. So next, an electric toaster of resistance 80 ohm takes a current of 10 ampere. Here again resistance is given to us, current is given to us. Calculate the development, heat developed in 2 minutes. In 2 minutes. So again you will use heat formula, but right now you will use the another heat formula. What is the next heat formula? I square RT, where your current is 10, your resistance is 80, time is 2 minutes. So first of all you are required to convert minute into seconds. So minute will be converted into seconds, so 2 into 60. Hence 100 multiply 64 00 into 2 into 60. Okay, 6 2s are 12, 12 into 64. How much is it going to get? 96. 96. 1 2 3 4 5. 9.6 into 10 raised to 5 joule. Your heat energy will be released. 9.6 into 10 raised to 5 joule. Okay. Voice is not audible. Check it whether voice is possible or proper or not. Chalo. Next. Calculate the rate at which heat is developed in the filament of a bulb of resistance 100 ohm. Your resistance is given to us such that a current of 0.5 ampere flows through it for 10 minutes. 10 minutes time is given to us. Okay. Rate at which heat is developed. Rate of heat. Rate of it. So actually we have to find rate of heat means rate of energy. Rate of energy is nothing but power. So we have to find power. So what is power? Power is equal to, now heat is equal to I square RT. Power is equal to H by T. So you can say it is just I square R. Power is equal to I square R. Your I is 0.5. R is 100. $25. Or capital W, then also it's fine. 25 watt. 25 watt would be the answer. Next, two resistance wire of the same material and of equal length. Material is also same, so raw will be equal, and length is also same. L will be also be equal. Of equal diameters. Hence area will also be same. So resistance must be equal. Are first connected to a parallel and then in series in an electric circuit. What is the ratio of heat produced in parallel and series combination? So you can consider that there are two resistors. One is R1, another is R2. and both of them are same, which is equal to R. Both of them are same, equal to R. Now ratio of heat produced in parallel and series. So for parallel, what will it be? 1 upon Rp, 1 upon R1, 1 upon R2, 1 upon R plus 1 upon R, 2 by R, so R by 2. R by 2 will be your Rp. Rp will be equal to R by 2. Similarly, your Rs is R1 plus R2, which is equal to R plus R, which is equal to twice R. Rs. Okay. Now, heat is equal to I square RT. I square RT. Current is going to be same. There is no change in current. There is no change in time. So it is just change in resistance. Okay. So H1 upon H2 or HP, heat for parallel and heat for series, would be equal to IP square or I square RT over I square RT. Okay. This is Rp and Rs. Otherwise, I and T are to be same. So this will be cancelled out. What is left? Rp over Rs. What is your Rp? P R by 2. What is your series connection? Twice R. So this will also again cancelled out, and your final answer would be 1 upon 4. So what is the ratio that you can consider? 1:4. Okay, ratio क्या निकलेगा? 1:4 का. $400 joules of heat is produced per second. So heat is given to you per second in a 4 ohm resistance. 4 ohm resistance. So R is given to you. What is the potential difference across the resistance? You are to find V. You are to find V. So again, you will use formula. Actually, 400 joule of heat is produced per second. Actually, heat is given, and per second it is given. So what can you say? Your power is equal to heat by time. So 400 upon 1 is equal to 400 watt. So they have provided you the power. They provided you power. Power is given. You are to find potential difference. P is equal to V square by R. That is the formula for the power. Now P is 400, V square, resistance is 4. So V square is equal to 4 multiply 400. Hence V is equal to 40 volt. V is equal to 40 volt. Simple. Next, in the circuit diagram given below, calculate A, the current through each resistance. Current through each resistance. So we are to find I1, I2 and I3. But in order to find I1, I2, I3, we should know what is capital R, what is total resistance, Rp. Okay. The total current. So total current, so we can find easily, because we have Rp, with the help of Rp, and and voltage V. We will find total resistance. The total circuit resistance when a battery is connected. So the order is in opposite direction. That is also fine. If the question is given you in such a form where you cannot find A, आप A find नहीं कर सकते जब तक आपको B या C नहीं मिलता. तो अगर आपने कोई भी तरीके से लिखा होगा, पहले A फाइंड किया, पहले B फाइंड किया, पहले C फाइंड किया, उससे कोई फर्क नहीं पड़ता. You can change the order. That's what you fit easy to find. Okay, तो order change करने से कोई फर्क नहीं पड़ता. You will have same answers. Okay, current through it resistors. So Rp or 1 upon Rp would be equal to 1 upon R1, 1 upon R2, 1 upon R3, 1 upon 2, 1 upon 5, 1 upon 10. 5 plus 2 plus 1 upon 10. 8 upon or 10 RP would be equal to 10 upon 8, 2 4s are 2 5s are 5 by 4. 5 by 4, can we say it is 2.5 ohm. So we know RP. With the help of RP, we can find current, total current also. I is equal to V by R. V is 6, 2.5, so 25 into 10. Again, 5 2s are, 5 5s are, and 2.4 voltage. Current would be 2.4 voltage. Now, as they have asked individual currents, so I1 would be equal to V1, sorry, V will be same upon R1, 6 upon 2 is equal to 3 ohm, I1. I2 is V upon R2, so 6 upon 5. So your I2 would be equal to 1.2 ohm. So my mistake, it is ampere. And I3 would be equal to V upon R3, 6 upon 10, which is equal to 0.6 ampere. You will get your I1, I2 and I3. Clear? Okay. Calculate the total resistance of the given circuits. Here 5 different resistors are given to you. I'll just help you to understand what is to be done. Rest of how to calculate, you do it by yourself. First of all, in order to find total resistance for this, what will you do? This is in parallel connection. This is in parallel connection. So first of all, you will find RP, and then combination of these two will be in RS, in parallel. After parallel, you will have series combination. Similarly, this will be your RP, and this will be your combination of these two will be your RS. In this case, you have two RPs, but both of them are in series connection. So these two in series connection. All of these are in series, and then combinedly they are in parallel connection. This is very important. Actually, you will learn about this in higher grades, in 11th, 12th grade. Okay. What will happen over here? You will find this two is in series connection. This two is in series connection, and combination of this two in parallel connection. So here are electricity chapters get completed. Electricity chapter gets completed. Okay. We will be having light chapter, sorry, human eye chapter over here. We have 3 chapters of physics in this entire book. So for 3 chapters, electricity is completed. This is our human eye, and then we will have light chapter. Okay. Just a sec. Now, next chapter, first question. The near point of a hypermetropic eye is at 75 centimeter from the eye. What is the power of the lens required to enable him to read clearly a book held at 25 centimeter from the eye? So, first of all, hypermetropic eye is given at 75 centimeter from the eye. The near point of hypermetropic eye is 75 centimeter from the eye. What is it said? That what is the power of the lens required to enable him to read clearly a book? Okay, what is the power of the lens required to enable him to read clearly a book held at 25 centimeter from the eye? So we are to find power. We are required to find power. Now, for that power, what is important? The important part is distance. We need to find focal length. Hypermetropic eye, it has been said that it is 75 centimeter and book is at 25 centimeter. So what will you say your focal length is? Your focal length is 75 minus 25, which is equal to 50 centimeter. That would be your focal length. Now, power is 1 upon f. Power is 1 upon f. But for power, your focal length must be in meters. So 50 centimeter when converted into meter, it will become 50 into 10 raised to minus 2, or you can say 50 by 100. 50 by 100 meter. So 1 upon f will show us as 100 upon 50. Hence it is 2 diopter. What will be your power? It will be 2 diopter. Clear? Again I am repeating. Hypermetropic eye is given to us, which is at 75 centimeter. Okay, hypermetropic eye, defective eye, and means where your image has been formed behind the lens, and over here behind the retina, and over here your book is kept at 25 centimeter from the eye. So first of all, you will find focal length. The focal length would be equal to 50 centimeter, and then we will use power formula to find the answer. But do not forget, sometimes we forget that power should, for power to find, your focal length must be in meters. We calculate directly only. So first of all, convert that into form of a meter. Okay. A person cannot see the object distinctly when placed at a distance less than 10 centimeter. When placed at less than 10 centimeter. What is the power of the spectacles that he should use to see clearly the object placed at 25 centimeter? At 25 centimeter. Okay. So now for this, again what will you do? It is said 10 centimeter distance, less than 10 centimeter, he cannot observe. So same thing, your focal length would be equal to 25 minus 10, which is equal to 10 centimeter, 15 centimeter, and then power is equal to 1 over f. 100 divided by 15, we'll say it as 100 divided by 15, and 5 3s are 5 2s are 10, 20, 3 6.66. 6.6 diopter. 6.6 diopter. Or you can have similarly 6 diopter. You can have 6 diopter also. And 6.6 diopter is difficult to prepare, so we'll make 6 diopter. Lens of 6 diopter. A person needs a lens of power negative 0.5 diopter, and for correction of her vision, what kind of defect is in vision does she have? It is negative power. So negative power, when does negative power occurs? Negative power occurs when it is a myopic eye. So the first answer would be myopia. Okay, myopia would be the first answer. And then it is said what is the focal length and nature of corrective lens. We have to find focal length and nature of the corrective lens. So for focal length, simple, f is equal to, would be equal to 1 upon p, which is equal to 1 upon negative 4.5, which is equal to 10 upon 45 negatively 5 nines are 5 twos are. Okay, and you can have your focal length as, you can let it be negative 2.5 also, but actually in exam you should be calculating it and converting it. Now this is in meters, so we can multiply it by 100 to convert into centimeter, and 200 upon 9. Okay, so your focal length would be 22 centimeter. Okay, 22 centimeter would be your focal length. 22.22, but you can have roughly as 22 focal length. Okay, and nature of the what is the focal length and nature of the corrective lens? Nature, what kind of lens it would be? For myopic eye, we use concave lens. Concave lens for the myopic eye. Okay. A myopic person can see clearly only when the object lies between 10 centimeter and 100 centimeter. Okay, the range is given to us of 10 centimeter to 100 centimeter. Which lens will enable him to see the moon clearly? Here the answer is quite obvious. Clearly it was answered up in the above previous question. It is a myopic person. So for myopic person, what kind of lens will be using? We'll be using concave lens. Okay, concave lens will be the answer. Okay. Good evening, Vidu. Next. A person can see the objects lying between 25 centimeter and 10 centimeter from his eyes. His vision can be corrected by using lens of power negative 0.1 diopter. So again, it is a myopic lens. Is this statement true or false? So first of all, it is said object lying between 25 to 10. The range is given to us as 25 to 10. So focal length 25 to 10 you can consider. So what will be the power for 25 centimeter? Power is equal to 1 upon f. So 1 upon 25, 100, 4 diopter, and for another power, 10 diopter. Okay, but over here we have 0.1 diopter. So what will be the answer? It is false. It's a false statement. Next, the distance of the distinct vision of a person is 50 centimeter. The vision of a person is given to us as 50 centimeter. He wants to read a book placed at 25 centimeter. Displacement of the book is given to us as 25 centimeter. What should be the focal length of the spectacles? Same thing, same power question. Again, you will find first power, displacement is given to you. With the help of displacement, you will find the focal length. 50 centimeter is already given to us. Okay, so with the help of it, you will find the focal length. A person wants to read a book placed at 20 centimeter, whereas near point of his eye is 30 centimeter. Near point is given to us as 30 centimeter. Calculate the power of the lens required. power of the lens required. Again same thing, power of the lens P is equal to 1 by F formula will be using, है ना. You also have near point, and you have near point, it is given to us, so myopic eye, and book is placed at 20 centimeter. A far point of a myopic person is 4 centimeter. Same question of myopia, 4 meter. Calculate the power of the lens he requires to look at the stars. Okay, same myopic question. Again, you will be using P is equal to 1 by F. Near point of higher metropic eye is 50 centimeter. Calculate the power of the lens to enable him to read a book at 40 centimeter. Now it is hypermetropic eye. Okay, so for hypermetropic eye, opposite to the myopic that we do, instead of subtraction, we'll be doing the addition. Okay, the same thing, P is equal to 1 by F. A person with myopic eye cannot see the objects beyond a distance of 1.5 meter. What would be the power of the corrective lens used to restore proper vision? Same myopic question it is. We'll be using the formula P is equal to 1 by F to find the answer. For a normal person, the far point is at an infinite and near point is at 25 centimeter in front of the eye. The cornea of the eye provides a converging power of about 40 diopter. 40 diopter converging power, and the least converging power of eye lens behind the cornea is about 20 diopter. Estimate the range of accommodation of a normal eye. What is the range of accommodation of the normal eye? So 40 diopter is given to us, and least converging power of the eye is of the cornea is 20 diopter. So for the higher range, for the higher part, what will you do? 40 diopter plus 20 diopter, which will be equal to 60 diopter. This will be the high point, and 40 diopter minus 20 diopter will be 20 diopter. This will be your lowest point. So the range is 60 diopter to 20 diopter. That will be your range. Okay, that will be your range. Okay. Just a second. A young boy can adjust the power of his eye lens between 50 diopter and 60 diopter. His far point is infinity. What is the distance of his retina from the eye lenses? We have to find distance of retina and the eye lens. Okay, so for that, what will we do? The power of the lens is given to us as 50 diopter to 60 diopter. 60 diopter is the highest one, so we'll use that to find retina's position. So retina's position would be equal to, position of the retina would be equal to 1 upon P. F is equal to 1 upon P, 1 upon 60. 1 upon 60. Now that is in form of meters. So multiplied by 100, 100 upon 60, 2 3s are 2, 5s are 3 1s are 3, 3 6 are 18, 66. Focal, or your position of the retina would be 1.66, or you can say 67 also by rounding it off centimeter. Position of retina. Retina would be from at point 1.67 centimeter. What is the near point? What is the near point? For near point, you will take the least power, which is 50 diopter. So 1 upon F is equal to 1 upon P, 1 upon 50 multiply 100. F would be, sorry. Near point is given to us. For that, we will take difference of the power. 60 diopter and 50 diopter it is. So the range is 10 diopter. Hence, we will take F as 1 upon be 1 upon 10 diopter, which is 1 upon 10 multiplied by 100. It will be 10 centimeter. Near point would be 10 centimeter. Okay. A myopic person having far point 80 centimeter uses spectacles of power -1 diopter. How far can he see clearly? How far can he see clearly? Okay, 80 centimeter far point is given to us as 80 centimeter, and power is given to us as -1 diopter. So with the power, what can we say? With the help of power, what can we say? We can say that focal length is 1 upon p, which is equal to 1 upon 1 into 10 -1 100. So -100 focal length centimeter, -100 centimeter it would be, and far point is given to us as 80 centimeter. Far point is given to us as 80 centimeter. So with the help of these two values, what will we do? Your maximum range would be equal to 180 maximum range would be equal to 1.8 meters. A 14-year-old student is not able to see clearly to question writing on a book placed at a distance of 5 meters from him. This is a classroom situation. Name the defect in vision he is suffering from. What kind of diseases or what kind of defect in his eyes he's been suffering from? It is not able to see near objects, so it is a myopic disease. So myopia. Name the type of lens for myopic eyes. What kind of lens will you be using? You will be using concave lens. And state two causes of these defects. Two causes of defects, same thing it would be that you uses. Yes, correct beta, it is myopia. So for what will you what kind of defects you can consider it as? That the defect of myopia is because of elongated lenses, defect in the eye lens, okay, or similar to it, you can say the curvature is of the eye lens is greater, but it is same thing. Okay, so mainly because of the disease or the defect is been caused because of elongation of your eye lens, elongation of the eye lens, elongation of eye lens. Okay, elongation of eye lens that causes this defect. Okay. Next, a person suffering from far-sightedness wears the spectacles having a convex lens of focal length 50 centimeter. What is the distance of the near point of this eye? Same question it is. Okay, so I am letting it for you to solve. Excessive curvature, yes, excessive curvature it is, excessive curvature, or you can say elongated lens, because excessive curvature is because of elongated lens becomes more thinner lens results to greater center of curvature. Okay, a person suffering from far-sightedness wears the spectacles having a this question I said that same. Okay, same kind of question it is. You will solve it with the help of power. Okay. The far point of myopic person is 80 centimeter. far point of myopic person is 80 centimeter, and in front of the eyes. What is the nature and the power of the lens required to correct the defect? First of all, far point is given. So for far point, what can we say? It is just hypermetropia, and nature of the lens, it would be convex lens, and sorry, for that it will be have a nature of the lens, which would be hypermetropia, and it will be convex lens. And what is the one of the lens called? For the power, as it is given 80 centimeter, with the help of power, what will you, for the power, what will you do? Power is equal to, power would be equal to 1 over f. With the help of this formula, you will be finding your power. Okay. Same question. Mostly from human eye, this numericals will be asked from power only. There is nothing much more to be asked from this chapter, or the lens formula, or mirror formula. These are the three important things in this particular chapter. Other than this, it is very less to be asked. For the numericals in physics, the important part is, for what is required, it is to be electricity. More electricity questions will be asked from the entire physics. Numericals always. The weightage of numericals in the physics part is from electricity. So I would say that in electricity, other than numericals, if you won't do anything, then also it is fine. Numericals are going to be asked mostly from the electricity chapter. So do very thorough preparation of electricity chapter. Okay. But other than that, in human eye, it is very less. For it is just power formula and lens formula, and other thing for light, it will be lens formula and mirror formula, nothing more. Earlier it was prism formula, but now it has been removed from your syllabus. Okay. Now, a person wears eyes of glass, focal length 70 centimeter. What is far point of the person? Same question. Power formula. P is equal to 1 by f. With the help of it, we will be finding the answer. Okay. A person cannot see the object beyond 30 centimeter distinctly. State the nature and focal length of the lens required to correct this defect of the vision. Now, ideally it is 30 meter. So far point problem, it is hypermetropia, and state the nature of the focal length of the lens required for far point, or you can say for that defect. What will you use? Convex lens. A person needs a lens of power negative 5.5 diopter, and for correcting his distant vision, for correcting his near vision, he needs a lens of power 1.5 diopter. What is the focal length of the lens required for correcting? Okay, just a second. A person needs a lens of power this much for correcting his distant vision. For correcting his near vision, he needs lens of power plus 1.5 diopter. What is the focal length of the lens required for correcting distant vision and near vision? So they have provided both the things, power for distant vision, power for near vision. So same thing you will use. P is equal to 1 by f, 1 upon negative 5.5 multiplied by 100. That would be, f would be equal to 1 upon negative 5.5 multiplied by 100. That would be your for near distant vision, and for near vision, power is equal to 1 by f. So f would be equal to 1 upon 1.5, f upon 1.5. Okay. Further, if you will calculate it, it will be 1000 upon 55, 5 11s are 5 200s are. Okay, so somewhat it would become 11 ones are 11, then 90, 11 eights are 18. Okay, so it will be something around 18.2 centimeter, but it is negative focal length would be, and for this multiply by 100, by 3, 200 upon 3, it will be somewhat around 66.66. so okay, round it off as 66.6, positive 66.6 centimeter. Again, I am repeating, do not forget to have this, let's say, unit, because more problem is that you have solved everything, you have done everything correct, but because of unit you will lose your half or 1 mark. Okay, it depends on the examiner how much to deduct, but something is deducting for us from our marks, so you know only, so why not to write it. Next, a person suffering from myopic was advised to wear corrective lens of power 2.5 diopter. A spherical lens of same focal length was taken to the laboratory. At what distance should a student place an object from its lens so that it is formed an image at a distance of 10 centimeter? Okay, so concave lens is given because it is a myopic eye, so it is concave lens. Okay, for this it is already given to us as image of a distance. This is V given to us as 10 centimeter. Focal length we will find using the diopter F. F would be equal to 1.2.5 into 100, which will be 1000 upon 25. 25 40 is 40 centimeter here will be your F. You have V, which is equal to 10 centimeter, and what is required to be found? U. U is what? Okay. So lens formula, what is it? 1 by V plus 1 by U is equal to 1 by F. Okay, so the lens formula you will be using. So over here, over here 1 by U is equal to 1 upon 40 minus 1 upon 10, 10 minus 40 upon 400, or you can have 1 minus 4 upon 40. So U will be equal to 40 upon 3, negative 40 upon 3. Hence U is equal to negative 3 ones are 3, 3 threes are 9.33 centimeter, negative 13.3. Now negative sign is nothing but it is just for convention. It is just for convention. Okay, so sign convention. A student uses spectacles of focal length negative 60 centimeter. Name the defect of the vision he is suffering from. Negative 60 centimeter focal length it is. Okay, so negative means it is a myopic eye. So myopia. Name and which lens is used for the correction? So it is a concave lens. Concave lens will be used, and compute the power of this lens. As already it is given negative 60. So with the help of it, you will be finding power. The far point of a myopic person is 80. So is it the same question? Ravi kept a book at a distance of 10 centimeter from the eyes of his friend Hari. Hari is not able to read anything written on the book. Why? 10 centimeter. So he is not able to observe 10 centimeters. So what kind of disease it is? It is a hypermetropia, near point problem, and a lens of focal length 5 centimeter is being used for a student in the laboratory as a magnifying glass. His least distance of distinct vision is 25 centimeter. What magnification is the student getting? Okay, so with the we have to find magnification. Okay, what is the magnification? So for that, it is already given to us distance of position. Position is given to us as u over here, and this is given to us as the focal length. So lens, the length of the focal length 5 centimeter. F is given to us over here as 5 centimeter. With distinct vision is 25 centimeter. That's fine. Magnification is to be found. Okay. Now 1 by v plus 1 by u is equal to 1 by f. U will be equal to v will be equal to 1 by f minus 1 by u, 1 by 5 minus 1 by 10, 1 upon 10. So v is equal to 10. Your v will be equal to 10 centimeter. Now as you got your v, and with the help of u, with the help of v and with the help of u, we will find magnification. Magnification is equal to u by v, which is equal to 10 upon 10, which is equal to 1. Magnification do not have unit. Magnification do not have unit, so you will have the answer as just 1. Next, a person suffering from short-sightedness can see clearly only upon a distance of 2 meter. Only upon a distance of 2 meter. Find the nature and the power of the lens required to correct his vision. Okay. Now, short-sightedness. So for short-sightedness, it is myopia, and again it is only upon 2 meter. It has been said. Find the nature and the power of the lens. Nature would be equal to concave lens, and power you will find with the help of 2 meter. Okay. Same kind of questions are being asked from this chapter. Nothing more. A person cannot see clear object beyond 1.12 meter. Far-sightedness. So hypermetropia will be used. The defect is hypermetropia. Name the defect of the vision he is suffering from. What would be the power of the corrective lens used to restore the proper vision? So with the help of 1.2 meter, you will find the power also. The near point of man. Again, near point of a person suffering from hypermetropia is 75. Calculate the focal length. Focal length you will calculate using the 75 centimeter. Okay. Power of the lens required enable him to read the newspaper, which is kept at 25 centimeter from his eyes. Okay. So again, for the power, first of all you will find the focal length, and with the help of focal length, because this is the 25 centimeter, u is given to you, v is also given to you as 75. With the u and v you will find focal length, and with the focal length you will find power. Least distance of a distinct vision of a long-sighted person is 40 centimeter. He wishes to reduce it to 25 centimeter by using spectacles. Find the nature and the power of the lens used. Okay. From 40 centimeter to 25 centimeter he is to bring it down. Okay. So from far to near. So for that, what kind of lens is being used? Concave lens, convex lens has been used. Okay. And so nature and the power, for the power what will you do? Difference of 40 and 25, and then with the help of that difference you will find the power. A convex lens is used to study the material of a glass slab. Given that the object distance from the glass slab is 10√3 meter and air is at 3 into 10⁸ meter per second. What is to be found? U is there, and speed is given. Speed, distance. Bit time is to be found. Time is to be found. Speed is 3 into 10⁸. distance is 10 root 3, so time would be equal to speed distance upon time, so speed distance is 10 root 3 upon 3 into 10 raised to 8. Okay, so you can have it as root 3 into 10 raised to minus 7 upon 3 seconds. That much would be your time, although it is half question, I guess. Next, a concave lens has focal length of 20 centimeter. At what distance from the lens a 5 centimeter tall object be placed so that it forms an image at 15 centimeter from the lenses? Also calculate the size of the image formed. Okay, so here you will be using a concave lens is already given to us as a focal length 20, so f would be equal to 20 centimeter. At what distance from the lens a 5 centimeter tall object distance, object height is given to us, so HO is equal to 5 centimeter, forms an image at 15 centimeter. V is given to us as 15 centimeter from the lens. Also calculate the size of the image formed. Okay, so with the help of V and F we can find U. 1 by V plus 1 by U is equal to 1 by F. 1 by U is equal to 1 upon 20 minus 1 upon 15. 3 minus 4 upon 60. So U is equal to negative 60 centimeter. U will be equal to negative 60 centimeter. Now magnification is equal to object upon image, object upon height of an object upon height of an image, and magnification is also equal to V by U. Okay, so if you will calculate both of them, V by U is equal to HO by HI. V is given to us as 15, U is 60. Negative here also will be used. Sorry, it is not there. And HO, height of the object, is given to us as 5. So 5 upon 5 meter or centimeter, meter only, and HI is to be found. So HI is equal to 5 multiply 60 upon 15. So height of the image would be equal to 20 centimeter. Both the formulas of magnifications are important. Both formulas of magnification. Okay. With the help of both the formulas, any one quantity among 4, object position, object height, image position and image height, all 4 of them are interconnected with one another. So if you try to find any 3, maybe 2 or more than 2 are given to you, then you can find the 4th one. Okay, so for that magnification, you are not required to know magnification, you are just need to know relation between both the formulas. Okay, next, just a sec. an object 50 centimeter tall, an object 50 centimeter tall is placed at principal axis of a convex lens. Its 20 centimeter tall image. So this is height of the object and height of the image. Height of the image is formed on the screen placed at a distance of 10 centimeter from the lens. So this is u given to us as calculate the focal length. We are to find f. But in order to find f, the first important part is to find v. Okay, first important part is to find v. So you will be using the same thing, height of the image upon height of the object is equal to v by u. Okay, is equal to v by u. V is equal to not known, u is equal to 10. So image is 20 upon 50, v is known and 10. So v will be equal to 20 multiplied 10 divided by 50. 4 centimeter. Okay, so your object will be formed, or the image will be formed at 4 centimeter. Okay, so now as you know your object distance, so we'll be using the lens formula, 1 by v minus 1 by u is equal to 1 by f. 1 by v means 1.4 minus 1.10 is equal to 1 by f. 10 minus 4 by 10 is equal, 40 is equal to 1 by f. 6 upon 40 or 40 upon 6 will be your f. So 2 3s are 2 20s are 6.67 centimeter will be your focal length. The focal length would be equal to 6.67 centimeter. Okay. The object 2 centimeter height is placed at a distance of 60 centimeter from a wide screen on placing a convex lens at a distance of 32 centimeter. Height is given to us, object height, place a distance of 64 centimeter. U is given to us, placing at a convex lens at a distance of 32 centimeter. So if you consider this is your wide screen, and this is object placed, height of 2 centimeter and distance between them is 64. On placing a convex lens at a distance of 32 from the object. So this is 32. This distance is 32 from the object. It is found that the distant image of the image is formed on the screen. So image is also formed on the screen over here. What is the focal length of the convex lens and size of the image formed on the screen? Now this is 32, this is also 32. The image distance and the object distance, both of them are same. So what kind of what is the position of the object you can consider it as? It is on center of curvature, and if it is on center of curvature, what can you say the magnification is? Nothing, because height remains same. So your h would be magnification. Magnification would be same, would be 1. Magnification would be 1. Focal length is been asked. Focal length. So for focal length, what will we use? We'll use distance formula. Focal length formula. Okay. So f is equal to 1 by f is equal to 1 by u plus 1 by v. V multiply V plus U, so 32 plus 32 divide by 32 into 32, which is 2 upon 32, 1 upon 16. So F is equal to 16 centimeter. Okay, we got our F is equal to 16 centimeter. Focal length is 16 centimeter. Ray diagram to show the formation. So this is the ray diagram, and imagine the position of the object with respect to the lens. Okay, so this will be the formation of the ray diagram. Although it is required to make neat diagram, I just did it for solution, but you are required to have a proper ray diagram. Next, a convex lens has a focal length of 10 centimeter. 10 centimeter focal length. At what distance from the lens should the object be placed so that it forms a real and inverted image 20 centimeter away from the lens? Okay, real and inverted image. So convex lens, convex lens has been used, and what would be the size of the image formed if the object is 2 centimeter height? So again, same thing it is. You will be using lens formula and magnification formulas to find the answer. The refractive index of the glass is 1.50 or 1.5, and the speed of the light in air is 3 into 10 raised to 8 meter per second. Calculate the speed of the light in glass. Now here the mistake that we usually do is in writing the formula. So object is traveling from air to glass. Okay, air to glass. It is traveling from air to glass. So rarer to denser. Object is traveling from rarer to denser. So how to remember it as? This is the refractive index nu, traveling from rarer to denser, R to D. So when R is given as the first will not be on numerator, it would be on denominator. So speed in the first place, so rarer part would be your speed of air, speed in air. So will be VA, and glass, so velocity in glass. Clear? Velocity in glass. So now 1.5 is equal to Vg over 3 into 10 raised to 8. Wait, by mistake. These are inverted. V, D and R. So denser, refractive index rarer to denser. We will write denser. Where it is entering, we will be writing it as first, and where it is been generated, it will be over here at the last. So V, after writing over here, Vg over V vacuum. So VA over Vg. So 1.5 is equal to 3 into 10 raised to 8 upon Vg. Vg would be equal to 3 into 10 raised to 8 divided by 1.5. 1.5 2s are, so Vg would be equal to 2 into 10 raised to 8 meter per second. Okay, this would be our answer. At what distance should an object be placed from a convex lens of focal length 18 centimeter to obtain an image at 24 centimeter from it on the other side? What will be the magnification produced in this case? Same thing, magnification formula. Image is given to us, position of the image, position of the object. Both things are provided to us. Okay, with the help of both the values, we finding magnification. Okay. Next, how far should an object be placed from a convex lens of focal length 20 centimeter to obtain its image at a distance of 30 centimeter from the lens? Okay, so focal length is given to you 20 centimeter. It is a lens, So lens formula will be used and image distance is given to us as 30. F is equal to 20, V is equal to 30. What will be the height of the image if the object is 6 centimeter tall? So HO is equal to 6 centimeter, HI is to be found. Okay, for that you will find U also. So 1 by V plus 1 by U is equal to 1 by F. 1 by V is 1 upon 30 minus, 1 by U is equal to 1 upon 20 minus 1 upon 30. 30 minus 20 upon 600. So U will be equal to 60. U will be equal to 60. Now as you know U, as you are aware about value of U, you will find HI over HO is equal to V by U. HI is, we don't know, HO is 6. So HI over 6 is equal to V is 30 upon 60. 32s and 2 3s. So your HI to 3 centimeter. Your height of the image would be equal to 3 centimeter. The image of an object placed at 60 centimeter in front of the lens is obtained on the screen at a distance of 120 centimeter from it. So U and V is given to us. Find the focal length. So with the help of lens formula, we will find the focal length. What would be the height of the image if the object is 5 centimeter high? Same question. Okay. The image of the, if the image formed by the lens is diminished in size. So when it is when will it become diminished? When it is a convex lens, size and erect for all the positions of the object, what type of lens it is. Okay, as I said, name the point on the lens through which a ray of the light passes undeviated. Non-deviation, where deviation does not occur on the principal axis. An object is placed perpendicular to the principal axis of a convex lens of focal length 20 centimeter. On convex lens, 20 centimeter focal length F is given to us. The distance of the object from the lens is 30. U is given to us as 30. Find the position of the magnification, the nature of the image formed. So U is given to you, F is given to you. With the help of U and F, you will find V. Okay, with the help of U and F, we will find V. So 1 by V will be equal to 1 by F, which is equal to 20 minus 1 by U, which is equal to 30. So same thing, it will be 60. Your V will be equal to 60 centimeter. Okay. Position V we found magnification M is equal to V by U, 60 by 30. So 2 centimeter. Sorry, 2, only 2. Magnification is 2. The nature of the image formed. Now, nature of the image formed is virtual image. Why? Because in convex lens, magnification will be more than 1 only and only if it is virtual image. Otherwise, it is always going to be diminished. Okay. So, here you have virtual image. Also, you can find it with the help of focal length and this. Okay, with focal length and this. Okay. But the important part is magnification is double, so you can say that it is virtual image. Draw a ray diagram to show the formation of image of an object placed between infinity and the optical center of curvature. Okay. Means from beyond center of curvature, you will draw the ray diagram of. And a concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. Calculate. Again, you will be using lens formula. Focal length is given to us as 15 and image 10 centimeter. So V is also given to us as 10. So you have to find U. Okay. Okay, so here our class ends. I hope it would be helpful for you, although the important part is practice. Okay, don't try to learn something new for this 3-4 days. Try to understand and try to remember all the important topics, all the important things that you already know. Okay, about physics I would recommend electricity. Cover as many as questions you could of electricity. The most questions will be asked from electricity only. Okay, chalo, let us keep it till over here. We'll meet again for other chapters. Bye bye. Thank you.